What is the speed of light? 299,752,400 something. They rounded off to 300 million kilometers per second squared. But if you look at it from the top, you'll see that I haven't violated anything. This looks like what happens in nature. So I was like, okay, so they gave me the patents to this, but you'll see that there's 6 unaccounted electrical poles to it. So I was like, what happens when 12 bubbles meet if you go to the one right next to it? Another stable structure that we basically see in nature, but there's 4 unaccounted electrical poles to it. 4 spin around it. You can count those 4. You'll see 1 at the bottom and 3 on those sides. This is the basis of crystallization, laws of crystallization that forms. And you can go to the last one. I was like, what happens when 24 bubbles meet? This is a negative space. If you pull to a horizontal on it, this is a negative space where 24 bubbles meet. This is where you cannot distinguish this from the background because all of the electrical potential has been accounted for. This would be the Bose-Einstein condensate, where something becomes indistinguishable from the fabric of space itself, the final state of matter. And the proof of this, the Platonic solids, they have a thing called discrete symmetry. You can put the cubes together, maybe you can put the dodecahedrons together, but you can't put all of them together. But you can take the wave conjugations right here, and they form supersymmetrical systems where everything aligns. So there's a site that James sent over to you, and this will be the final thing, and then I'll be quiet for a second. But because this is this right here. Now these are other sculptures I've built. There's a video, and you'll see that flower. If you'll pop it up from Terry's linchpins that he sent you, you'll see, and this is one of 4 supersymmetrical systems that I patented. And the reason I patented it was because when Walter Russell put his stuff up, you have to just go down a little bit, and we're going to get to gravity. Not that one. We're going to get to gravity in a second. Not that one. We're not even there yet. There, Tetrotarian wave conjugations. Now, these are all of those systems put together. This is where 12 bubbles meet, the Aubrians. Mm-hmm. And then I put 5 of them together, and they make these natural starfish. But then when I put 10 of them together, they lay themselves out, and they predict all distribution of matter within the electric field. And you can see where 6 bubbles meet as you get to a higher point on it, those where 6 bubbles are meeting, still fitting perfectly where the 12 bubbles are meeting and where the 4 and where the 8. That's a supersymmetrical system. I put 12, if I put 20 of those where 6 bubbles meet, the Antonians, they make a natural dodecahedron that's naturally curved. If I take where the 12 bubbles meet, that's where I made the linchpin from, ultimately from some of those pieces you got right there, that all shape of it. So that was one of the first things. But when Walter Russell came out with his book and he introduced his periodic table, he watched as different people went up and collected Nobel Prizes for deuterium, for tritium, for all these things that he had discovered. And I was like, okay, let me wait until the patents are granted before I'll talk about it.